It's time for an AM5 build video. The first, probably guaranteed-ish, stable DDR5 6000 256 gig build, as a matter of fact. 9950X3D, that's the processor I've picked. This is a high-end build, probably one of the highest-end builds with AM5 that you can do. We can even do off-roadmap U.2 storage, 8, 16, 32 terabytes in U.2. You can attach that to AM5? Yeah, you sure can. Let's do a build video. So this is the build, but I'm going to walk you through the process. This is based on our Fractal North case. And I've got the glass side panel, but this is also available with the mesh side panel. The Fractal North case is affordable, but kind of stylish. It's pretty expandable. It's pretty flexible. You probably could use this case for a couple of builds over the years. It has two Type A USB ports on the top and a Type C port, separate headphone and microphone jack, which I kind of like versus the combination port. It's pretty expandable in terms of what you want to do with the fan configuration, like how you want to mount the fans in the top and the back. You can't actually do a rear mounted fan. I have not done that in this build. I didn't find that it was necessary. With the mesh side panel, instead of the glass side panel, it comes with an extra fan bracket that sits here that you can see in some of our other build videos. Now inside, I have an MSI. It's the X870 Tomahawk. I've also got the B850 Tomahawk. The reason for picking these MSI motherboards is because they have, from what I found, the best compatibility with our 256 gigabyte G.Skill kit. If you're not read in on the struggles of getting 4 DIMMs to work on all desktop platforms, whether it's Intel or AMD, when you're going to run 4 DIMMs on a desktop motherboard like this, like an AM5 class motherboard, it's tough to get all 4 DIMMs to work at a very high speed. The speed that they're rated for is in 2 DIMM configurations, 1 DIMM per channel, and 2 DIMM configurations, 2 DIMMs per channel. Normally, AMD AM5 only guarantees DDR5 3600 when you're running all 4 DIMMs, and they guarantee DDR5 5600 when you're running 2 DIMMs. Now, most kits, like the sweet spot for Ryzen, is an Expo profile, DDR5 6000, and 99.9999% of chips can do that no problem, and G.Skill and other have kits for that. We've done a lot of builds around, you know, two DIMMs configurations running a DDR5 6000. That's pretty much what everybody runs. What sets this apart is this is 4 DIMMs that actually really will run at DDR5 6000, assuming you've got a really good motherboard and that you hit the silicon lottery with your particular CPU. It can be a little more challenging with X3D CPUs for whatever reason, but in this system, I've got a 9950X3D, and that's probably the big reason that you're watching this video. Is like, this is the, you know, top end 256 gig configuration for 9950X3D. Who needs 256 gigabytes of memory on an AM5 platform? It's 16 cores. If I were to put my contrarian hat on, I would say 256 gigs of memory for 16 cores isn't really a good balance. We've still only got 2 channels worth of memory bandwidth, and the I.O. controller on the 9950X, on all AM5 CPUs really, is a little bit weak. We're talking 50 to 75 gigabytes per second, when really with 2 memory channels running a DDR5 6000, we should be able to achieve much more memory bandwidth than that. And in fact, server platforms do achieve much more memory bandwidth than that. And so the rate at which we can move information in and out of memory is bottlenecked somewhat. Surely 256 gigs of memory is too much for this platform. It doesn't make sense. And for a lot of workloads, that's true. If you're running a lot of virtual machines, and the virtual machines are not really doing a lot in the background, there's not a lot of CPU demand for them, like you're doing simulation, you're doing like Windows Active Directory fleet experimentation, that sort of thing. Having a lot of memory makes it really easy to switch context between a lot of different virtual machines. If you're running like 6 or 8 or 10 virtual machines that have 4 cores each, but you might have 8 to 16 gigabytes of memory allocated for lab or experimentation purposes, not for server purposes. Even if you go epic on AM5, I don't know that I would recommend that. Then it can make sense to have 256 gigs of memory. If you're doing certain kinds of scientific or compute workloads where you need a lot of system memory and footprint, and it doesn't make sense to move up to a Threadripper platform, 256 gigabytes of memory can make sense. If you make a task and leave a ton of stuff open at once, and you want to switch quickly between a lot of different open applications, 256 gigabytes of memory can make sense. And with this configuration, you don't trade off memory speed for capacity. If 128 gigabytes of memory gets it done, however, that's my recommendation. Like 120, unless you know you need 256 gigabytes of memory, 128 gigabytes of memory in 2 DIMMs on this platform is luxuriant. The sweet spot for price is actually 96 gigabytes of memory for high capacity. So you get 2 48 gig DIMMs. And again, DDR5 6000 for that configuration, no problem whatsoever. But this platform was the first platform that I tested with both Y-Cruncher and MemTest 86, more than 24 hours stability with the brand new Kit of 4 G-Skill Trident Z Neo Expo designed for AMD. So that is a big deal. And there's a whole separate video on that. You should check it out. And I've explained my reasoning on motherboards. There's a whole separate video where I tested the 256 gigs with a bunch of different motherboards. You've got some other options for motherboards if like the I/O configuration or whatever else doesn't make sense. Our X870E version of this motherboard has USB 4. It's got a lot of USB connectivity at the rear I/O, HDMI. It also has 5 gig onboard Ethernet. I really wish that was 10 gig, but MSI does have their godlike. You can trade up to the highest end X870 boards from MSI, get 10 gig, and also still have good 256 gig compatibility. I did not have that motherboard on hand to test, however, but I have reason to believe that the X870E godlike will work because they copy paste a lot of the aspects of those. And then when they come down the stack, they're doing cost optimization. So usually they don't get themselves into trouble when the higher end board is being cost optimized. The higher end board usually performs as good or better than the lower cost board. And this is a lower cost board than the godlike. So, disclaimers aside, there's also a bunch of Asus boards that are really good. Asus and MSI are far out in front in terms of supporting 256 gigs at 6,000. Now, the other boards that we review have been fine at DDR5 3600 for 256 gigs as well. So there you go. Our Fractal case comes with 2 front fans. I've opted not to add any other extra fans to this configuration. Sometimes it does make sense to add a fan to the rear for extra exhaust. It depends. You use Hardware Info 64 to keep an eye on your temperatures. Now, for cooling, this is a Noctua NDH15. This is overkill, and it is a giant dual tower cooler. Both of these towers, have heat pipes that touch the CPU basically, and then we've got these 2 big fans. And this fan has to be offset, and it just barely fits with the glass. And this is because the memory, the fan is sitting on the memory. Normally, when you only have 2 DIMMs, the fan will sit down and occupy the place where the second DIMM in the channel closer to the socket will occupy. And so you could slide the fan out of the way if you're not running a 4-DIMM configuration, in other words. In a 4-DIMM configuration, it has to be offset a little bit. That's the genius of the Noctua design. It works great. Noctua is the Cadillac of cooler. Like, you're paying for a premium, but they're good and reliable, and they will last a long time. And this is meant to be a low-maintenance system. If you want something that's a little bit more affordable, that is 85% as good, might I turn you on to the FSP MP7. We've also reviewed this cooler and taken a look at this cooler in other configurations. There's a black edition. This is what it looks like on a motherboard. You can see that this is quite a bit smaller. It's less surface area. It's going to run hotter. But with the 9950X3D and an AMD CPU, those AMD CPUs really don't consume all that much power to begin with, even at full load. So even at full load on our 9950X3D, the MP7 is a perfectly reasonable cooler that's going to keep everything cool. And I like that this is, a little easier to work with, and there's no offset necessary when we're talking about a 4-DIMM configuration. So if you want to save a few bucks and get this cooler, this is an excellent cooler that is physically smaller and all of that, and it's available in this configuration as well as a blacked out configuration. So depending on what you want, perfectly reasonable choice. Generally, I like a tower cooler versus an AIO, especially for AM5, because again, it doesn't produce that much heat. You don't really gain a lot in extra boosts or extra performance from going to the expense and complexity of an AIO. I mean, sometimes an AIO can make sense depending on what you're building and what your goals are. But for AM5 and longevity, I'm leaning more toward tower cooling, which is kind of funny because on Threadripper, I'm all about AIOs. So I'm weird like that. with these certain AIOs. But that's a different video. Now, in here you might notice that there's a 7900 XTX. Isn't this the era of the 9060 and the 9070? Surely an RX 9060 XT, this particular one from Sapphire, would be a much better choice in a build like this. If you're doing light gaming and you don't really want to put a lot of points into your GPU, this is a fantastic choice. And this particular one from Sapphire is also a fantastic choice. We've reviewed separately. We actually have a bunch of reviews of 9060 and 9070 XT GPUs. They are amazing gaming GPUs. This particular GPU, so Newegg has or had, hopefully I get the video out in time, a bunch of like refurb return 7900 XTX GPUs, 24 gigs of VRAM, that cost about the same, slightly more than a 9060 XT, and that is the deal of the century. This machine is going to be used to work on some things that already exist in the ROCm space, like programming stuff, and the AI stuff has already been shown to work for the 7900 XTX, and I got 24 gigs of VRAM. So it made a lot of sense for the 7900 XTX. That said, there's a huge difference in the RDNA generations, and I've really been impressed on the gaming side for the 9070 and the 9060. So if you just need a GPU for like light gaming, the 7900 XTX probably isn't it. It probably is worth going to the 9070 XT or 9060 XT, something like that. But the Sapphire Nitro gets a special plug in this video because this is a really, really good deal right now on Newegg. You know, all thing import considerations and all things otherwise considered. And also Micro Center, also not bad for Micro Center. So you get some options for a GPU. You know, NVIDIA, more on the NVIDIA side, you can see that this case, you know, this is a 5090, a Founders Edition 5090. Founders Edition 5090 will be no problem in this case configuration at all whatsoever. So you can go the NVIDIA route as well. The Founders Edition is nice because it doesn't block your other slots. If you go with not the Founders Edition, any slot, you've got 3 slots before your next PCIe slot on this particular MSI motherboard. If you go with a larger GPU, it has a chance of blocking the slot, or a peripheral will be right up against your GPU, which would hurt its breathability. So I like the Founders Edition. Now, as I've got it configured, I've got a Seasonic 850 watt power supply in here. I also would recommend FSP Group, the Hydro G. This is also 850 watts. This is a modular power supply. This works great. It has the 12V2 style power connector. If you pick up some variants of the AMD GPUs also have the 12V2 connector. I've got the Tai Chi 7900 XTX as well, which did show up in the Amazon or in the returns program thing that was going on. But this uses the standard 8-pin connector, 3 of them. This power supply is good no matter which way you're going to swing there. 850 watts for a build like this is a little overkill, but I think makes sense because you've got a little bit more headroom to upgrade. So like if you get a new processor in the future or a new motherboard and processor, theoretically these motherboards can deliver more than 140 watts to the AM5 CPU. So having a little bit more headroom on your power supply for that, or having a little bit more headroom for an upgrade in the future for your GPU. I mean, the 5090 is 600 watts. So from 600 to 850 watts, you've only got 250 watt power budget for the entire rest of the system. This is the minimum power supply for a 5090 in a build like this, IMHO, and really you'd be better off with a 1000 watt power supply. Let's talk storage. We've covered cooling and the CPU and the motherboard and the Ys and the memory and the Y. And the GPU, to an extent, it's dealer's choice, your choice, depending on what you're trying to do. Is this a high-end gaming machine? Is this, whatever? If you were going to build a 9800X 3D machine for gaming, I would probably make a lot of different choices along the way, because there's a lot of this that you don't need just for the highest-end gaming machine. Like, you really don't. But if you're doing computer science work or programming or like learning AI and doing that sort of stuff, this gives you a lot of options and possibilities for connecting the dots there. But storage, if you're an enthusiast and you like doing lots of fun stuff with storage, storage is the first place you can go completely off the rails. So let me start if you want to not go completely off the rails. That's the crucial. What's in here and what I've tested is a T705. What I would actually recommend is a T710. T710 is a minor upgrade to the T705. You basically can't get the T705 and the parts that went into the T705 they can't get, so they didn't also call it a T705. Let's not punish Crucial for that. They correctly said, well, we can't get exactly the same parts. Let's call it the T710. T710 is a little bit better than the T705, a little bit better flash media quality, made some improvements to the controller, a little bit less power usage, which is less heat output. And this M.2 does require a heatsink, a substantial heatsink. You're going to want to make sure that you properly install it. It's going to work better in an M.2 slot on a motherboard where it is above the GPU rather than below it, as is the case on MSI's layout and design. Nice job, MSI. Not always the case. Double check your motherboard. This is an absurdly fast 15 gigabyte per second, no nonsense M.2. This is the easy button solution. 124 terabytes, Crucial has you covered. No big deal. There's a lot of other choices you can make here that are good too. Kingston is not bad for this kind of thing. I need to test Kingston more, but we've got a lot of these around the office because we've been using the crap out of them for AI. And for the AI workloads, we absolutely have shredded them. Like, we've copied petabytes of information, and when you're dealing with some of these AI models, it's 200-300 gigabytes at a time. It's like uninstalling and reinstalling Call of Duty 3-4 times a day. It's that bananas. And these have held up well. Really, really well. Way better than my Samsung drives. I spent a bunch of money on 980 and 990 drives, and the 990s have been really disappointing, let me tell you. The 980s have been okay, but I've been impressed by how much better these have been over the long haul. And I really spent some money on some 4 terabyte 980, Because of the struggles with M.2, there is another option. This is the off-road thing I was alluding to. This is a Memblaze 7A40. Memblaze, they've been in business for 5 years. You've probably never heard of them. But, Asia Pacific Rim, if you're in that area, these are harder to get in America, and then the tariffs and all this other kind of stuff. The PCIe Gen 5. This is a U.2 form factor. It looks like a 2.5-inch drive. It's wait, is that SATA? No, this connector is PCIe. This is 4 lanes of Gen 5 PCIe. And you can plug this in to a PCIe slot. You can get an adapter that lets you slide this into PCIe, or you can do an M.2 adapter. Now, the reason you wouldn't want to do a PCIe adapter in a desktop AM5 system like this is because it'll drop your GPU down to 8 lanes. You don't want that. What you can do is get an adapter like this. This is M.2 to MCIO. MCIO is the name of a server connector, a type of server connector that's popular in servers for delivering PCIe lanes wherever they need to be, whether that's PCIe slots at the back of the chassis or drive bays like this at the front of the chassis. A lot of server motherboards have these kinds of connectors to give the system builder flexibility to decide how they want to use PCIe lanes. And this is different from and apart from a normal PCIe slot, but it's just PCIe lanes. It runs a PCIe Gen 5. This one is an active adapter because it's got chips on it that help you do redriving and retiming of the signal, which is important. The PCIe Gen 5 signal is so fast that you can't just use a passive cable. If you look for M.2 to U.2 adapters, you'll find cables like this, or you'll find adapters. There's no chips on this. This is just wires. This doesn't work. Even if it says it's PCIe Gen 4 or PCIe Gen 5, that is lies. It is not true. It does not work at PCIe Gen 5. You need the redrivers and the retimers. And in fact, some of these are PCIe Gen 4 only, not Gen 5. But you can pick these up. It's about $100 to $150, give or take. They used to be about $70 before the tariffs in America. And so, just depending on where you are. If you're in the Asia region, it's like $50 US. They're very, very affordable. Anyway, this thing plugs into this cable via that MCIO connector. And then boom, you've got the connector here. You can plug into your drive. And there you go. And this is 8 terabytes of extremely high endurance storage that looks and operates just like an M.2 that was self-contained on this card, but you've got a lot more, as a manufacturer, you've got a lot more room in a 2.5-inch drive like this. This is better in terms of cooling. This is better in terms of engineering. This is better in terms of physical room to put the flash media. This drive is better in every way for workstation workloads than anything that you would get in an M.2 format. But as far as the computer knows, as far as the computer in the BIOS thinks, this is just a normal old M.2. There's nothing special about this. The only trouble you can get yourself into with a setup like this is the signal integrity. And so if you use a good adapter, you'll be fine. And this is a great way to have workstation storage. A lot of Threadripper workstations from Lenovo and HP and others, they'll build this form factor or sometimes the E3 form factor. This is a Kioxia E3. This is another good choice for workstation storage. And so it looks a little different. The connector's a little different, but physically it's a physically different connector, but it's still, not quite a 2.5-inch drive. It's a little bigger, it's a little flatter, but electrically it's still just PCIe lanes. This is 4 PCIe Gen 5 lanes. This is 4 PCIe Gen 5 lanes. And so you can get the appropriate adapters and be able to use that no problem. And this is 8 terabytes of ultra high-speed flash storage. And this is kind of the entry level. Well, you can get 4 terabytes pretty affordably, but then 8, 16, 32 terabytes in a workstation, it's pretty phenomenal. This is also enterprise class stuff, so it's a little more expensive. So I'm hoping you're doing work with that as opposed to playing games or just playing games. But having that kind of capacity in an AM5 workstation is no problem, just with the right cables. And I wanted to show you that because basically everybody should be doing that. Oh, and I'll give a special shout out to ASUS with their Crosshair X870E Hero. If you look carefully at this motherboard, it has a connector on the front that's a slim SAS connector. That is only rated for PCIe Gen 4, and that connector goes through the chipset. That's why it's only Gen 4. But it is an option. You can get a cable to go from that to a drive like this, and it'll operate at PCIe Gen 4 speeds instead of 5, but that is an option for putting this kind of storage in your workstation. If you don't need PCIe Gen 5, you don't want the bleeding edge in terms of speed or anything like that, the Gen 4 options on eBay, because those are old and kind of getting shredded and stuff, that's an option, and you can use that, just plug and play with this board. You don't need the M.2 adapter, you can just plug it directly into the motherboard. But understand the trade-off. Like plugging into the motherboard, it sounds like it's simpler and better, but it's not, because it's actually better to use those PCIe Gen 5 lanes, or at least the lanes directly into the CPU, not through the chipset. Lower latency, higher performance, better all around. So I like the M.2 adapter route as opposed to built into the motherboard route, unless you get a Threadripper motherboard. And a Threadripper motherboard, these connectors are also starting to show up there. ASRock has true MCIO connectors on their Threadripper motherboards, as well as the PCIe Gen 4 Slim SAS style connectors. It's just a signal integrity thing. And ASUS on their Threadripper motherboards also has the Slim SAS style connectors, but no MCIO connectors. They cheaped out. I don't know why. So yeah, fun times. But for storage, know all the goodness about storage. I can hardly believe it. This is our build, and it's running at DDR5 6000, 256 gigabytes of memory. Rock solid stable on Linux, Y-Cruncher, Memtest 86, more than 24 hours with Memtest 86, 24 hours with Y-Cruncher. Not a single detected error on our 9950X3D 16 core. Now this particular CPU came from Micro Center, and the GPU came, that was the Newegg like refurb 7900 XTX special. Nice, very, very nice. I'm very happy with how this build turned out, and it's a perfect choice whether you're going to go with a Windows operating system or a Linux operating system. This is pretty much the top shelf AM5 build that you can do right now for 256 gigabytes of memory. This is definitely one of the easiest boards for getting that running. Right now, we're talking September 6th-ish, 2025, with the state of the BIOSes and everything else. These MSI boards are definitely the easiest to get 256 gigabytes of memory working on, quickly followed by ASUS. And that's really it. That's really it for this build. I've got the Keychron, the K10, with the nice wood grain accents. It's a very satisfying keyboard set up with this build. For monitors, I would probably pair it with an OLED. We've done reviews recently of Asus, Gigabyte, and ASRock. The Asus has held up the least well, mostly down to firmware bugs, but like the firmware is buggy if you're trying to run your display at a relatively low brightness. It'll actually like do the display saver and make it brighter than the lower brightness that you've set, which is absurd. But the Aorus and the ASRock OLEDs are holding up really well. And if you're building a build like this, you're probably going to splurge for a higher end monitor, right? A higher end 32-inch 4K monitor. I mean, OLEDs, it's hard to beat. So check out those videos, check out this build, use our links, hit us up in the forum. If you do use our affiliate links, we might earn a small commission. So thank you for that. And thank you to our patrons and subscribers and everybody. And yeah, if you like put something together like this, hit us up in the forum, take pictures, show us what you got going on. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.